This video covers literal equations. We're just going to go through the example problems that you were given. Number 1, we're solving for t. So what we're going to do is we're going to divide both sides by IR. And the reason is because the t and the IR are separated by multiplication. So the inverse operation is division. On the left side, I get P divided by IR. On the right side, I get T, and we're finished because we got T alone. Number 2, I'm going to use two methods. The first way is going to be a way that takes longer. So I'm going to use the distributive property. Then I'm going to subtract. Actually, I'm going to subtract the 2L. And then I'm going to divide both sides by 2. So W is equal to A minus 2L divided by 2. This can be rewritten. You could write that W instead equals A divided by 2 minus 1L, because 2 divided by 2 is equal to 1, so it would be a negative 1L. I could simplify it further and write A divided by 2 minus L. I had a student in class say we could also write it as 1/2 A minus L. That's also another option. And I'm going to show you one other method. In the method that we just did, we used the distributive property. That was step 1. We subtracted 2L, which is step 2, and then we divided by 2, which was step 3. You'll notice that when you do these problems, you'll find faster ways to do the same problem. So let's do the same problem, but let's use fewer steps. So instead of using the distributive property, the first thing I'm going to do is I'm going to divide both sides by 2. So I get A divided by 2 equals L plus W. Then I'm going to subtract L from both sides. And I am finished. So that was 1 step, dividing by 2. 2 steps was subtracting the L, and then we're finished. So that was a little bit faster. Number 3, we're solving for y. So when you look at y, where the y is and where the 2x is, these two terms are separated by subtraction. If they're separated by subtraction, you're going to use addition or subtraction to get rid of the 2x. I like to leave what I'm trying to get alone where it is. So I'm just going to leave it on the left side. It was on the left side to begin with, so that's where it's going to be at the end. And I'm going to get rid of everything else on that side. So I'm going to start by subtracting 2x from each side because that was a positive 2x. I'm left with negative 3y. On the right side, I get 8 minus 2x. Then, since the negative 3 and the y are separated by multiplication, I use the inverse operation, which is division. So my answer is 8 minus 2x, that quantity divided by negative 3. And you're finished. If you want to write it differently, you could write this as negative 8/3 plus 2/3 x, and how I did that is I just took the 8 and divided it by the negative 3, and then I took the negative 2x and divided it by the negative 3. Number 5, we are solving for x. So the first thing I'm going to do is I'm going to multiply both sides by 3. On the left side, I get 3/3, which equals 1, so I'm just left with x plus y. Then I subtract y from each side, and I get x equals 15 minus y. Number 6, we're solving for b. So if you look at the b term and the mx term, they're separated by addition. So that means that to get rid of the mx, we're going to either subtract or add. So if this is a positive mx, I'm going to subtract mx from each side. On the left side, I get y minus mx. On the right side, I get b. So my problem is finished. Number 7, we're solving for y. So the by term and the ax term are separated by addition, which means that to get rid of the ax, I'm going to add or subtract. I leave this y with the coefficient of b alone, because whatever I'm solving for, I like to leave it where it is. I'm going to move the AX by using inverse operations. And then the final step that I'm going to take to get y alone is I'm going to divide by b. Since the b and y are separated by multiplication, the inverse is division. So I can leave it as c minus ax over b, or I could write this as y equals c over b minus ax over b. Both of these are acceptable. Number 8, we're solving for b. Once again, if you remember from the last problem, it takes more time to use the distributive property first. So I'm not going to use the distributive property. What I'm going to do is I'm going to divide by h. And then b and c are separated by addition, so I need to use addition or subtraction to move c to the other side. Since it's a positive c, I'm going to subtract c from both sides to get b alone. Final answer. Number 9, we are solving for L. So to get L alone, since L and WH are separated by multiplication, I'm going to use the inverse operation, which is division. So all of our math rules still apply, but when we're finished, when you're dealing with literal equations, you don't have an actual number value for an answer. You have a set of variables and maybe a number or two mixed in with it. We are solving for r squared. 4 and r squared are separated by multiplication. The inverse is division, so I divide both sides by 4. A divided by 4 is equal to r squared. All right, number 11. We're solving for h. Since the h is separated from the pi r squared by multiplication, the inverse would be division, so I'm going to divide both sides by pi r squared. So I get h equals v divided by pi r squared. Number 12, we're solving for x. These two terms are separated by subtraction, so I know that I'm going to use subtraction or addition to get rid of the y term. Since we're subtracting y, I'm going to add y to both sides. And then the final step for getting x alone is division. That's the inverse operation. And then another way I could have written this was x equals 2 plus y divided by 7, or plus 1/7 y. Number 13. To get y alone, I'm going to multiply both sides by 2. 2 divided by 2 is equal to 1. 1 times x plus y is just x plus y. And then I'm going to subtract x from each side. Number 14, I need to get I alone. I don't like to have that variable in the denominator. It's going to make it difficult to solve the problem. So I just simply divide both sides by I. On the left side, I get IR. On the right side, I divided by I is equal to 1, and 1 times E is just E. And then from here, I divide both sides by R to get I alone. So this was a case in which I didn't actually leave what I was solving for alone. I moved it, and the reason was because I had a fraction here. So I had a few more steps I had to put into the problem. So I equals E divided by R. Number 15, we have a fraction again, and we're trying to get the z alone. So what we're going to start by doing is we're going to start by multiplying by 6. So I get 6x equals, and the 6's will give us 1. 6 divided by 6 equals 1, so I'm left with yz. And then the final step to get z alone, trying to get z alone, is y. Divide by y. I get 1z on the right side, and on the left side I get 6x divided by y. Number 16, we're solving for L. So the first thing that I'm going to do here is I'm going to multiply by 2L. So I get 2LA, that'd be the same as 2AL or LA2. The order there doesn't really matter. So 2 times L times A is equal to, on this side, 2L divided by 2L gives me 1, so I'm left with 1R. I'm trying to get L alone, so I'm going to divide by 2A. 2 divided by 2 is 1, A divided by A is 1, so 1 times L is just L. On the other side, I also had to divide by 2A, so it's R divided by 2A. Number 17. Oh, it doesn't say what I'm solving for. Let me take a look. Number 17, I'm solving for B. So I'm trying to get B alone. So the first thing I'm going to do is I'm going to multiply by 3. I get 3A equals A plus B plus C. 3 over 3 equals 1. Then I want to get B alone, so I'm going to subtract A. And then I'm going to subtract C. And I get 3A minus C is equal to B. Number 18, we're solving for Y. So these two terms are separated by subtraction, so I need to use addition or subtraction to get rid of the 12x. The 12x is positive, so I'm going to subtract 12x from each side using that inverse operation to move it. Then I divide everything by -4. And we get y equals 3x minus 5. Number 19, we're solving for z. So I multiply both sides by 4. 4 divided by 4 is 1. And then I'm going to subtract 2y from each side. The last thing I need to do is I need to get rid of this -1, the coefficient that's -1. So I divide everything by -1, and we get -4x plus 2y equals a positive z. And the final problem, number 20. I multiply both sides by n. N divided by n equals 1. 1 times r minus c is r minus c. And then I add c to both sides. So Pn plus c is equal to r. R equals Pn plus c. And that's all the problems.